Hey, thanks for joining me in the Science Zone lab. Hey, have you ever thought about fire? You know, fire is interesting, isn't it? What would we do without fire? Well, you know, fire plays an important, it's important when it comes to nature sometimes. There's some type of trees that unless their seeds get hot enough, then they won't produce other plants. That's kind of interesting. But what do we need in order to have fire? Well, you know, we need three things in order to have fire. What we're going to do, we got an experiment, and we're going to show you those three things. Okay, first of all, we're going to need some fire. So I have a candle right here, right? And so I'm going to light my candle. And so when I light the candle is going to give us some light. Okay, so here we go. I got my safety glasses on because we're using fire. Have to be very, very safe. Okay, so here we go. There's my little candle. Okay, get that thing burning pretty well. All right, there we go. Now, what we have is I'm feeling heat. I'm feeling heat. So fire releases energy in the form of heat. Fire also releases energy in the form of light energy. That's interesting. Now there are three things that fire needs. One of those is heat. You have to have enough heat. So we ought to be able to take the flame away if we get rid of the heat, okay, from the flame. So what I've done is this. I've taken this is some copper wire right here, and this is a little Allen wrench. And so I've wrapped the copper wire around the Allen wrench, okay, to form a little coil, okay? And I don't know if you can see that or not, but there's a little hole through there. What we're going to do is we're going to try to take some of the heat away from the flame. If we can take enough heat away from the flame, then the fire should go out. The flame should go out. Okay, so I've got a long extension on here because this is going to get hot, okay? But copper is a very good conductor of heat, so we need it to be very, very long. All right, so here we go. I'm going to go ahead and put this over there, being very careful, okay? And the wick of the candle should go right into that coil right here. And what happened? What happened to the flame? Did the flame go out? Did the fire go out? It went out. Why did it go out? Because we took the heat away from the fire. We took the heat away from the flame. Hey, let's try something else with this. So we know that if we take heat away, that's one of the three things that a fire needs. Okay, so what are the other two things? Well, let's go ahead and light our candle back on fire. Okay, there we go. Let's get our candle lit again. All right, so here's our candle lit again. The other thing that a fire needs happens to be fuel. If you don't have enough fuel, then it doesn't have enough energy. It can't burn fuel. It's got to burn something in order to have a flame. So what we've done is we've taken a little piece of aluminum foil and we've cut some little V notch, okay, out of it. You can see the little V notch right there. So what I'm going to do is I'm going to take that wick and we're going to put that wick in the little notch. And that is going to keep the wax, okay, the candle wax is heating up, okay, the flame is heating up the candle wax. That candle wax, okay, turns into a vapor, and that's what that flame burns. It's burning a vapor, okay, of wax. So here we go. I'm going to slide this on here, and we're going to take the fuel, which is the wax, away from that. And let's see if we're going to run out. I think we ran out of fuel. We blocked the fuel because we're squeezing the wick, and so that can't go over there. Let's see what we got right here. Let's pull this back out. There we go. And the flame went out. Okay, so what have we learned? Well, we've learned that we've got to have what? We've got to have heat, enough heat to support the flame. We also have to have enough fuel. And so if we want to put out a fire, what can we do? Well, we can make sure that doesn't have anything more to burn, okay? Or we can take the heat away by maybe spraying it with water, okay, or something that's cool. Spread the fuel out around here so it won't get hot enough. The next thing that a fire needs, the third thing, is it needs oxygen. Now, you and I need oxygen in order to live. We've got to have oxygen. It's very, very important. Otherwise, we can't live. Well, a fire can't live without oxygen, at least not this kind of fire. So here we go. I'm going to go ahead and burn our candle again. Okay, there we go. Now, how can we take the oxygen away from that flame? How can we take an oxygen away from that flame? Now, it's hard for me to get the candle to burn again because what did we do? We took some of the fuel away, and there we go. Now that wax is heating up enough. Wax is heating up enough so that the wax is turning into what? It's turning into a vapor, turning into a gas, and that's what's burning. So if we want to take the oxygen away, what I have right here is I've got this little glass chamber, and I'm going to put it on top. Okay, I'm going to put it on top. Well, what's inside of here? What's inside of here is the same air that you and I are breathing, and about 21% of the air that you and I are breathing happens to be oxygen, and the other 78% happens to be nitrogen gas. So we're breathing just fine in the room, but if we take the oxygen out, and we can't breathe, we can't live. So we're going to take the oxygen out by putting this on top. Okay, we're going to put it on top of the flame. Remember, the fire is using the oxygen in the chamber. Okay, it's using the oxygen. Remember, it's only about 21% oxygen in there. As soon as it's burned up and used most of that oxygen or all the oxygen, what's going to happen to the flame? The flame should go out. It should go out. And so let's watch very carefully, and we should notice pretty soon that the flame is getting what? Well, it's getting smaller and smaller and smaller, and we're going to have less heat because there's less combustion, and pretty soon the flame is just going to go out because all of the oxygen is going to be gone. In fact, when that flame does go out, that means that we've used the oxygen up to where the candle is. But there's still going to be more oxygen below here, but since that candle flame is up high, we're using the oxygen up in the upper level right here. That's why if you're ever in a room that's burning or on fire, what do you think the oxygen is? The oxygen is heavier and it goes down. Okay, here, can you see? We're running out of energy. The flame is getting smaller and smaller and smaller. The oxygen is using up, and so there's less oxygen. Pretty soon there's no oxygen. We're burning less bit of oxygen, and we should get a little bit of smoke up here. And you see any fire? I don't see any flame. I don't see any flame at all. So here, let me take this off right here. Let me take this off. And if I feel the top of this right here, it's warm. In fact, it's really, really hot right there. Why? Because the flame was right there, but this is cool down here. Hey, let's see another thing that we can do with a candle, which is interesting. Well, what we can do is we can prove that the candle is burning the what? The wax. That's right. We have a vapor. We have that candle wax turning into a gas, actually, and that's what it's burning. So what I'm going to do is I'm going to light the candle on fire. Okay, here we go. Let's get that candle going again. Okay, there's enough oxygen in the room so we can burn the candle. Come on, there we go. All right, here we go. All right, so we got a nice deal going on. Now, what I'm going to try to do is this. What I'm going to try to do is this. I'm going to go ahead. We're going to use this. Remember a coil of wire? The coil of wire took the heat away from the flame, didn't it? Okay. So what I'm going to do is I'm going to take the heat away from the flame. And when I did that, did you notice that there was some smoke that came up? Well, that smoke happens to be unburned fuel. Okay, unburned candle fuel. All right, and then I'm going to take this match right here, and I'm going to try to light that unburned candle fuel on fire. And let's see what happens with this. There we go. Can you see that? I'm going to put this down over here. Okay, let's try that one more time. Let's see if we can get this going right here. And we'll put this on here. Let's put it on there again. Well, you see that? That's pretty cool. It went out. And then all we had to do was to relight that, and it went on fire. How cool is that? So what did we learn? Well, what we learned was that there's three things that a candle needs, that a fire needs. It needs what? It needs heat, it needs fuel, and it needs oxygen. You can put any fire out as long as you take just one of those things away from the fire. How cool is that? I'm going to go ahead and blow this candle out. And let's talk about fire in a little different way. Okay, here we go. You know, sometimes there is a tornado, a fire tornado. So what we're going to do is we're going to make a fire tornado. So in order to make a fire tornado, what I'm going to do is we're going to need something that's going to spin, okay, that's going to spin. Now, if we have a fire like in a forest, okay, a forest fire, the flame is very, very hot, very, very hot, right? And so you have a tremendous amount of hot air, okay, going up with that flame, and all you need is some turning air. You need some blowing air. You need some wind, okay. And since you have all of that heat and you've got some wind blowing across, then it can form what? It can form a vortex. That's right, a fire vortex. Now, we're familiar with a vortex like in a bottle. And some of you may have. These are little vortex tubes right here. They're connectors where you can connect two water bottles together. These are like 1 liter water bottles connected together, and you just screw those bottles right into it. Okay, so that's what we've done right here. We've made this right here. Now, if you don't have one of these, you can take the two bottle caps. The two bottle caps, glue them together, and have somebody drill a hole through them, and then put them and just join them with some tape so you can make your own. But we bought this one. So here we go. So what I'm going to do here is I'm going to turn this upside down. Okay, there we go. All right. And so what we have is we have water up here, we have air down here, and the red stuff right here that you can see, that happens to be lamp oil. We put that there so that you can see the vortex. Now, a vortex is a spinning column of air, can be a spinning column of air, and also it could be a spinning column of what? Could be a spinning column of water. It can also be a spinning column of fire that we're going to see in just a little bit. So, in order for the water to go down here, there's air down here, there's water up here, the little bit of air right here, but the air takes up space. So if we want the water to go down, we're going to have to get rid of some of the air. So we're going to get rid of some of the air by forming a vortex. And the center of that vortex is going to be like a straw, an opening. It's kind of like the center of a tornado. The center of a tornado is a very, very calm area. So all I have to do is I'm going to spin this, okay? We need a spinning force. And let's see if we got a tornado in a bottle. Oh yeah, look at that. We've got a tornado in a bottle. The center of that tornado right here, the center of the vortex is like a tube or a straw, and the air is going up through the center, the water comes down, and that lamp oil made it really, really pretty so that we could see it. I love that. That is so cool. Hey, let's make our fire tornado. Shall we do that? All right. To make a fire tornado, what we have right here, and by the way, you can't make a fire tornado at home. You're going to have your parents help you, or your teachers, or whatever, or come on over to the Science Zone lab and we'll do one as well. So in order to do this, we're going to need a couple of things. First of all, I have a record player. Now you might say, what is a record? You know, have you ever heard about records? You know, when your parents, maybe your grandparents were around, you know what they had? If they wanted to listen to music, what they did, they may have had records. They had different size records. In fact, I have a record here that I wanted to show you right here. This is a long play record right here. And in order to get sound out of this, there's little grooves. Okay, there's little grooves in this plastic right here. In order to get some sound, what you had to do is you had to get a needle, and the needle would what? It would rub over those little grooves, and it would put vibrations in, and then they could pick that up, because in order to have sound, you have to have some kind of vibration. And they would amplify those vibrations. We could hear it as music. So I have a record player, and the record player, we can spin it. I can turn the record player on. I could spin it by hand if I want to, like this, and it makes a nice turntable. Okay, all right. Now, inside of this little cap right here, this little cup, I've got a couple of little tiny pieces of sponge, and we put a little bit of fuel right here, put a little bit of fuel, lighter fluid fuel right here. And then what we're going to do, in order to get that vortex, that spinning column, we're going to put this down on top of it. And then what I can do is I can just spin this by hand. And if I don't want to spin it by hand, then I can do it automatically, and we can turn that on, and it will spin for us. In fact, this has about 3 different speeds. And so we can get it slow, or we can get it medium, or we can get it to go really, really fast. Now, we're only going to do this for just a little bit, because it makes a little bit of smoke, okay? And we don't want to get a lot of smoke in the lab. So let's go ahead. Now, I have a lighter. I'm going to go ahead and light this with my lighter. We'll get our fuel lit. Okay, there we go. And I'm going to go ahead and put this on top. Okay, there we go. Let's see how, okay, that's pretty good. All right. And I'm going to spin it by hand a little bit. Now, do you notice that the flame, is it turning into a vortex? I think it's turning into a vortex. I'm going to turn this on, so now it's on automatic, and it's going to start to spin. Okay, cool. And the flame is coming up. All right, and we're going to go ahead. We're going to go ahead and we're going to increase the speed a little bit. Okay. Let's see how this is going to work for us. So we have what? We have hot air. That flame is very, very hot. Okay. And we're putting wind in there, or a current of air, because we're spinning this. This is really, really cool. See how this is working right here? Now, if this happened to be a forest fire, then that forest fire, the vortex of flame, can go up very, 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 very high. It can go up over the height of the trees, and it could start fires miles and miles away. That's interesting. So what I'm going to do, we're going to stop this. We're going to put this on off. Now we need to get rid of that fire. So what we're going to do, how do we get rid of a fire? We can take the heat away, we can take the oxygen away, or we could take what else away? What else away? The fuel. So I'm going to take the oxygen away. I have a little pan. I'm going to put it right on top of that can right there. And now it's not going to get any more oxygen, and the fire is going to go out. Let's make sure it's out. Yep, it's out. It's all out. So what I'm going to do is I'm going to go ahead and I'm going to move this over here. Let's get this out of our way, because we've got a couple other experiments, okay, that we want to do. All right. Now, we're still talking about fire. Remember, you have to be very, very careful with fire. Now, you know, there's one safety thing that I want to teach you about today. You know, some houses have burned down because they weren't very, very careful. Now, we have to be very careful about fire, but I've got something I want to show you right here. You know what this is, don't you? This is a 9-volt battery. Do you know that a 9-volt battery can burn your house down? You might say, what? That sounds crazy. Well, you know, it's not crazy at all. Now, do you have a junk drawer at home? You know, most of us have a junk drawer at home. I've got a few of junk drawers at home. But you know, if you store batteries or some types of cells in a junk drawer, and you don't take and cover the terminals, especially on a 9-volt battery like this, then the electrical energy can jump from one side to the other. All it has to do is to get a conductor or something to cross or to connect those two terminals. Now I want to show you. Let's see what we got. First of all, I have this beaker right here, this beaker of water, and I have something right here you might have at home. We use this for cleaning sometimes, and even for hobbies and stuff around the house. This is steel wool. Now, what's steel wool? Well, it's steel. It's really made out of steel, but it's little threads of it. It kind of looks like wool. That's why they call it steel wool. Now, if I can short these two terminals and touch it to the steel wool, look and see what happens. Let's see what happens if I do that. I'm going to touch this to two of those right here. Hopefully you can see that pretty well. Let's check this out. Can you see a little spark? Did you see a little spark? What's happening right here? Let's check that out. Can you see a spark going? Whoop, that's already stuck to there. You see that? Look at that. Those are little sparks. You know, it only takes a spark to get a fire going, doesn't it? It only takes a spark to get a fire going. And I have another 9-volt battery in that little cage over there by the door, and maybe we can try that other 9-volt battery. See if we can get that. See if we can get this battery. Oh, there! You see that little spark? See that little spark? So we're going to try another 9-volt battery right here, real quick, to see if we can get this 9-volt battery. Might not be very, very good. Okay, let's check it out. Let's see what we got right here. But that could start a fire, and that's not a good thing. No, we don't want it. We don't want a fire. But that can happen in your junk drawer. All we have to do is to get those two terminals, okay, to touch. And let's see what this may have a little more life in it. I'm not sure. Let's check this one out. Let's see what this one does. Oh, do you see that? Look at that. But that could turn into a flame, because that's hot. Those are hot. That's very, very hot. And all you have to do is to get those two terminals to touch, and then you've got a problem on your hands, and you've got a fire. And that could be a problem for us. So remember, you've got to protect the terminal ends of your 9-volt batteries. Otherwise, you could end up burning your house down, and that's not a good idea. Now, I have a strand of wire right here. You see how that happened right here? Now that's interesting. Let's pull a couple of more strands out of this right here, because it has to be the same wire, it has to be the same strand of wire in order for that to make a conduction. Isn't that interesting? Wow, that's interesting. It only takes a spark to make a fire go. That's interesting. I have this water in this beaker right here, and that can protect us in case this should start on fire for sure. That's interesting. Well, what I'm going to do is I'm going to put that down in the water right here. We don't want to cause a fire to happen in here. Not a good idea. Now, let's see. I've got something else right here that we're going to look at. Let's see what we've got. First of all, I've got a balloon right here, and this particular balloon is a very interesting balloon. The balloon happens to be what? The balloon happens to have a gas in it right here. In fact, that balloon has the very lightest gas that we know of in the universe. In fact, the lightest gas that we know of happens to be hydrogen. Now, hydrogen is a very, very light gas. In fact, as far as we know, most of the universe is made out of hydrogen. Now, I think that hydrogen is one of Jesus's favorite elements. I don't know why. Well, I know why. I know why I think it's because there's more hydrogen than anything else in the universe as far as we know. Could be something else, but we haven't figured it out yet. But hydrogen is a light gas. In fact, this balloon right here, it wants to fly away. It wants to fly away, but we've tied it down with a string. Interesting. Now, you may have some other light gases as well at home. Have you ever had a balloon full of helium? Yeah. Well, does a helium balloon float? Yes. A helium balloon does float in the air, but hydrogen will float a balloon even better because it's lighter. But the reason why we don't use hydrogen, okay, in a party balloon is because hydrogen has a tremendous amount of energy in it. It really does. And so we're going to show you the tremendous amount of energy. And so what I'm going to do is I'm going to take a match. Okay, I have a long matchstick right here, and I'm going to get kind of far away from this. But we're going to take and we're going to heat up that hydrogen balloon, okay, with a match. And what's going to happen? Well, I'll tell you what's going to happen. The balloon's going to break open because the match is hot. It's going to break that rubber part of the balloon. The hydrogen is going to come out, okay, and it's going to combine with oxygen in the air, and we're going to have a what? We're going to have a fireball. Well, that's what we're going to have, okay? Now I'm going to put a pair of safety ears on, okay, because this is going to be very, very loud, okay? And you're going to hear it. Now the recording might go a little dim because it does that electronically to protect everything, but it's just going to be very, very loud, okay? And then after this, then we're going to get another experiment, okay, so that we can finish up. All right, here we go. All right, so I'm going to go ahead and put my ear protectors on, and you might want to cover your ears too. All right, so let's go ahead. I'm going to put my ear protectors on. Okay, all right, that sounds good right here. All right, so I'm going to back up from here. All right, here we go. I'm going to back up. All right, and I'm going to put this over here. All right, so we got it down right here. All right, here we go. I'm going to start our match. I think I'm going to start my match. Okay, here's our match. All we need is a countdown. Let's go. 3, 2, 1, and whoa! 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 Did you hear that? Did you hear that? I heard a little thud. I didn't hear a big loud noise because I had those ear protectors on. You know, that reminds me. You know that sound can injure your hearing? That's right. Loud noises can injure your ear. Now, it doesn't have to be a popping balloon like the hydrogen balloon or a big bomb or a firecracker. It can be loud music. That's right. So we shouldn't play the music so loud that it's going to hurt our ears, okay? Could be just noise, like machinery, okay? Like machinery. So we have to make sure that we're protecting our ears. Hearing is a very, very important thing. Hey, I've got something else right here that I wanted to share with you. Let's check this out. Let's see what we got. I've got a little strip of something right here. Now, this is interesting. It's kind of a little silvery strip right here, and it happens to be one of the elements. Okay, it happens to be one of the elements that we find on the periodic table of elements. And it has a lot of energy stored up in here, and we're going to show you what that energy is going to be, okay? So here, let's go ahead and do this, all right? There we go. And this is called magnesium. Magnesium. Do you know that you and I, we have magnesium in our body? Do you know that we need magnesium in our body in order for us to have good health? That's exactly right. I wonder where we get magnesium from. Yep, you guessed it. We get it from our food that we eat. That's exactly right. One of those foods happens to be bananas. Bananas have magnesium. Other foods have magnesium in it as well. That's why it's so important that you and I eat a what? A variety of foods. We've got to keep those elements that we have in our bodies. We've got to keep them there. That's interesting. Now, you know what they can do with the magnesium? First of all, we use it sometimes in a laboratory. And magnesium burns. We can take a magnesium ribbon like this and we can burn it. Now, when we burn a magnesium ribbon, it gives off a tremendous amount of light energy. So what I'm going to do is this. I'm going to take and I'm going to start my match on fire right here. Okay, because we're going to need a lot of heat, and one match just might not work, so I'm going to use my candle, all right? Now, I have my safety glasses on. Yes, okay. This does not, I don't need ear protectors because it really doesn't make a noise. Now what you're going to see is a tremendous amount of energy being released from the magnesium. In fact, it produces one of the brightest lights, okay, that you'll probably ever see. It's extremely bright. All right, so here we go. So I'm going to heat it up. It takes a little bit for this to heat up enough. In fact, we have 2 pieces, and I think I'll do 2, but let's go ahead and try this right here. I'm going to put this in the hottest part of the flame. The hottest part of the flame is right about there. Okay, there we go. And it's got to heat up. And oh, and there it goes. Can you see how bright that is? Whoa. I mean, that is super, super bright. That is interesting, isn't it? Now, hey, let's take a look at that. Now, I'm going to put that, this is that burn part right here, and it's not hot right now because it cooled off very, very quickly. But you can see that in my hand right here. And if I squish it down, it just turns into powder. It just turns into powder. How about that? In fact, we could take that powder, and you know what scientists have done? They can take and they can make something out of this, and they can make something, a medicine that has that in it. That is so cool. Wait, let's try the next one. Are you ready for one more? Just remember, this is extremely bright light. And this is magnesium. Magnesium. Okay, here we go. Let's go ahead. Now, by the way, what am I holding it with? This is something that we use in a laboratory sometime. Now, it looks like a pair of scissors, but it doesn't cut anything. What it does is it holds on to stuff. Okay, so, and it has some little grippers right here. It looks like a pair of pliers on the end. I'm going to hold that. I'm going to put it down like this. Let me try to get this down here better than that. There you go. And I'm going to squeeze the handles. And when I squeeze the handles join together. They lock together. Now that's pretty cool. So this is holding it all by itself. I don't need to put both of my fingers in there to hold it like this. I don't have to do that. It's holding it all by itself. And scientists use this, and doctors and surgeons and other people, they use these. This is very, very interesting. Okay, remember what we did? We heated this up and we got it extremely, extremely hot. Okay, are we ready? All right, so let's hold it in the fire. We have to hold it in the fire for a little bit because it takes a lot of heat to burn this magnesium ribbon. Oh, it's starting up, and there it goes. There we go. Whoa. That is a very, very pretty light. It's a very, very bright light. In fact, you wouldn't want to stare at that light burning for very, very long because that's another thing that can hurt us. Did you know? That's right. Bright lights can hurt us. Bright lights from, if you have somebody that's maybe welding, can hurt your eyesight. Maybe it's even a laser. Laser beams can injure your eyes as well. That's interesting. So we always want to use eye protection when we're looking at extremely bright lights for any period of time. Now, I have my candle right here. Do you remember? Do you remember about how we could put the fire out on my candle? Remember, we need 3 things in order to have fire. We need what? We need oxygen. And we need what? We need heat. and we also need fuel. But you know, the Bible says something interesting about fire, doesn't it? It does. It says that you and I are supposed to be what? We're supposed to be the light of the world. We use fire, we use candlelight in order to see. But you and I are supposed to show others God's light, because some people don't know about Jesus' love for them, and we say that they're living in darkness. That's exactly right. So we need to let our light shine. Let your light shine. By letting your light shine, you're telling others about Jesus' love for them, and you're treating them like you would like to be treated. We're treating others the way Jesus treats us. Hey, I've enjoyed having you come today and join me in my lab, and I hope you'll join me the next time. So remember, every time we learn more about science, we're learning more about Jesus.